Hi chemists, I want to review the lab we did on Friday, the standardization of potassium permanganate, because this is a introductory laboratory, fairly sophisticated, and we certainly break it apart. So um, I am not expecting you to have access to all the calculations and all the equations immediately since we haven't formally covered it, but you have seen oxidation reduction reactions. So let me just go through the calculations um, because I want you to have the calculation. I want you to have your calculation for your concentration for your potassium permanganate ready to go. And so I want to review here for you. Let's start with the following equation. Potassium permanganate is a purple solid, and so I dissolved it in water and prepared a approximately 0.02 molar solution for you. And then you came into lab on Friday and you did a titration. Fabulous work, by the way, everybody. And you did, and through that titrations, you can determine a more precise concentration for the potassium permanganate to 4 decimal places. That's your goal. Potassium permanganate is very soluble, and when it dissolves in water, it ionizes 100% into potassium ions and permanganate ions. The potassium ion is a spectator ion and does not get involved in any way in the oxidation reduction reaction. And I show you this equation because it's possible when you are in moles to interchange both permanganate and potassium permanganate because it's a 1-to-1 mole ratio, and that becomes more important as we continue. Okay, here is the balanced net ionic oxidation reduction reaction for ferrous ammonium sulfate plus potassium permanganate. Spectator ions are removed. And we will definitely review this in much more detail, and I give it here to you now so that you can use it for your calculations. The significant thing is there are 5 moles of iron plus 2 for every 1 mole of permanganate ion. Potassium permanganate is a very strong oxidizing agent, and that's what an oxidizing agent does. It oxidizes something else. So the permanganate or potassium permanganate oxidizes iron plus 2 to iron plus 3, and in the process gets itself reduced from manganese with a plus 7 oxidation number to manganese with a plus 2 oxidation number. But the critical thing for the calculations for you is the fact that it's a 1-to-5 ratio. In this sample calculation for you, it turns out that 12.50 milliliters of potassium permanganate were used to arrive at that light pink endpoint that everybody was able to achieve on Friday. Ferrous ammonium sulfate hexahydrate, that is the name of the full compound that you used, that sort of lightish green that you used. I picked a value. Yours will be somewhat different than this. It may have 2 sig figs, may have 3 sig figs, depending on whether you use the milligram balance or the centigram balance. If you take the molar mass of this whole thing, you get 392.13 grams. You take your mass of the ferrous ammonium sulfate, divide it by its molar mass, and you get that value, 0.00115. You'll notice I took a little significant figure license, and this has 3, this has 5. Oh, I'm good to go. Never mind. Cancel that. So I have 3 significant figures in my mole value of ferrous ammonium sulfate. Great. FAS, ferrous ammonium sulfate, by the way. If I want to get the moles of permanganate ion, I have to divide by 5, and that's exactly what I do in the next step. For every 1 mole of this, 5 moles of that. If this is moles of ferrous ammonium sulfate, then I need to divide by 5 to get my moles of permanganate ion from the balanced equation. But remember what I said, when I'm in moles, the moles of permanganate equal the moles of potassium permanganate because it's a 1-to-1 ratio. We're not finding out the concentration of permanganate ion, we are finding out the concentration of potassium permanganate, but we find out the moles of permanganate first because it is in the balanced net ionic equation. I hope that makes some sense. Once I have my moles of potassium permanganate, to get the concentration, I divide by my liters. Concentration in brackets is going to be my moles of potassium permanganate divided by my liters of potassium permanganate I used in the titration, and I do the math, 3 sig figs, 4 sig figs, and so I will have 3 significant figures in my answer, 0.0184. We said it was approximately 0.02, but to more specificity, we have that value. This is the value that you will take forward into part 2 of this laboratory, which I will review with you on another video. Remember that molarity is, let me remove that. Ooh, what happened here? Let me remind you that molarity, capital M, is equal to moles of solute over liters of total solution. This should hopefully help you determine your concentration of your potassium permanganate and have that ready for class on Monday. Okay, hope that's helpful, and I will see you soon in another video. Bye for now.